Hello everyone, welcome back to the epic saga of solving the Laplace's equation. In this part, we'll continue to evaluate the second integral of the problems. So what is our second integrals? Our second integrals I2 is integral from 0 to delta of vx squared dy. Alright, so how do we evaluate this? Okay, remember the problems, they give us vx over vx infinity, right? So we have to make sure this term disappear, so that we can plug in what the problem give us. So the tricks to make it appear is to times vx squared and divide by vx squared. So you can see, so I say 0 to delta vx squared over vx infinity squared times vx infinity squared dy. Okay, we know that vx infinity squared is a constant. You can put it out, vx infinity squared right here. And then integral from 0 to delta of vx over vx infinity on that square dy. And now you can substitute in what the problem gave us previously, and it is vx infinity squared times integral from 0 to delta of 2 times y over delta minus y over delta square all of this square dy. Right? Okay, so what are we going to do now? Y'all remember we need to expand this out. So recall, I don't know what's the term for this. A square of a minus term. I don't know. But you have a theorem, right? Say a minus b square equal to a square minus 2ab plus b square. So 2 times y over delta minus y over delta square on the square. What does equal to? It equal to 2 times y over delta square minus 2 times 2 over y over delta times y square over delta square plus y over delta square on the square, right? I just apply the theorem. Let me highlight it for y'all. Okay, and if you expand it out and cancel, you'd have 4y squared over delta square minus 4y cubed over delta cubed plus 4y4 over delta 4. Wonderful, wonderful. Now you can substitute this term, the result we give right here, into our integral. So our integral become y2 equal to vx infinity squared times integral from 0 to delta of 4y squared over delta squared minus 4y cubed over delta cubed plus y4 over delta 4 dy. Okay, what are we gonna do next? Well, remember this is dy, so y is the variables, the rest you treat it as a constant. So what I'm gonna do is I'm gonna separate y on one side, so it's for easy integration to make it look nice. So 0 to delta 4 over delta squared times y squared minus 4 over delta cubed times y third plus 1 over delta 4 times y4 on this dy. And then you can definitely take the integral. So vx infinity squared 0 to delta 4 over delta squared. Remember, on this term I highlight here, let me just highlight for y'all, is a constant, okay? So what does it mean? It means that you just take on the y. So this become y3 over 3 minus 4 over delta cube times y4 over 4 plus 1 over delta 4 times y5 over 5. Okay. Let's go ahead and clean it up. So Vx infinity square delta 0 of 4y third over 3 delta square minus 4 y4 cancel out, so it's just y4 over delta third plus y fifth over 5 times delta 4. Okay, and now you can substitute in delta and 0 for y. So it becomes Vx infinity square of what? Of 4 times delta cube over 3 times delta square minus delta 4 over delta cube plus delta fifth over 5 times delta 4 on this minus 4 times 0 to the power 33 over 3 times delta square minus 0 fourth over delta third plus 0 fifth over 5 times 0 fourth. All right, what will you get? So you come Vx infinity square times on this becomes 0, 0, 0. And what does this become? It become 4 over 3 times delta minus delta plus 1 over 5 times delta. Okay, what does it become? I can pull delta out, become Vx infinity square times delta. What do I have left on the bracket? 4 over 3 minus 1 plus 1 over 5. What does this term equal to? Let me do draft right here. I put this is the draft. Okay, 4 over 3 minus 1 plus 1 over 5. 15 is a common denominator, and then you have 20 minus 15 plus 3. So it become 8 over 15. Beautiful number. So it becomes Vx infinity squared times delta times 8 over 15. Excellent, everyone. And we have finally evaluate the second integral. Now, we will use the result we obtain, and we can solve for delta in the next part of problem 2. Stay tuned, and I appreciate your attention. Goodbye.